Assalamu alaikum. Good evening to all of you. And today I want to deliver my virtual lecture regarding matrix algebra. So, can you hear my voice clearly? Okay. So, I hope you download the PowerPoint slides on the Blackboard. So I try to show you the PowerPoint slides. So today's our lecture is on matrix algebra. So first of all, we are going to discuss the addition of matrix. So there are, if in this case, we say that if we have two matrices A and B are both M into N matrix, then the sum of A and B denoted by A plus B is a matrix obtained by adding corresponding elements of A and B. So can you see the Blackboard clearly? Can you see the Blackboard? Yes, okay. And you see the PowerPoint slides clearly? Yes, okay, no problem. Because if I share the Blackboard, so addition of a matrix. So if A and B are both M cross N matrix, then the sum of A and B denoted by A plus B is a matrix obtained by adding corresponding element of A and B. So if A and B, and in case of multiplication, if A and B are both M cross N matrix, then the sum of A and B denoted by A plus B is a matrix obtained by adding the corresponding elements of A and B. So for example, we have two matrices A and B. We have some elements of A and some elements of B, and we are going to add these two elements, these two matrices. Then one by one we take we choose some element of A and some element of B. So this is a procedure. So we take the addition, first element of matrix A and first element of B, then adding that -1 -3 is equal to -2. This is the procedure to add these two matrices. Similarly, we can add rest of the elements. The next element is -2 plus 0 is equal to -2. Similarly, 2 plus 4 is equal to 6, and similarly rest of the elements I can add these elements. So this is the procedure to solve to add the matrix. So next element is -2 plus 0 is again -2. Similarly, again if I'm going to add -2 plus 4 is equal to 4, 5, 6. So this is the procedure. From this way we can solve the matrix. If whatever we have the big matrix, we can solve. We can add these two matrices in this way. So again, I'm going to move. If we have another element, what we get 0 plus 2 is equal to 2. Now next -1 plus 1, what we get 0. So in the next term, if we are going to add these two elements, then we get the 0. We get 0. Now again, if I'm going to add the next element -3 plus 3 minus 4, then what we get? We get -1 if we are going to add these two elements. So we get -1. So this is the procedure. to add the two matrices. So it is very easy. I'm repeating once again. How can I do? So if we have a matrix, then we have two matrices, and we are going to add them. Then add element by element, we can add them. Then again, if we have a matrix, then we can again the second element, and similarly the third element, we can add them. So if we are similarly move next, 0 plus 2 is equal to 2. Again move next, then minus 1 plus 1 is equal to 0. So in this way we can solve the rest of the matrix. 3 minus 4 is equal to minus 1. So this is the procedure. In this way we can add the two matrices. Now we move further. There is a law of matrices in Boolean algebra. The first law is called the commutative law. The meaning is that A plus B is equal to B plus A. This law is called the commutative law. Matrix addition is commutative. This law is called the commutative law. Again, matrix addition is associative. This law is also hold in the matrix. A plus B plus C is equal to A plus B and plus C. So these laws hold in matrix. So it is scalar multiplication of the matrices. No, the third point is scalar multiplication. So if A is an M cross N matrix and S is a scalar, then we let Ka denote the matrix obtained by multiplying every element of A by K. This procedure is called the scalar multiplication. Meaning is that if we are going to multiply any scalar with the matrix, then the whole matrix is multiplied by that element. That is called the scalar multiplication law is hold in the matrix. So let us assume that we have a matrix A. A is equal to 1, minus 2, 2, 0, minus 1, 3. We have a matrix, and we have some scalar 3, and we are going to multiply 3 to the matrix A. So then we have to multiply each and every element. We have to multiply 3. So 3 into 1, 3 into 1, 3 into minus 2, 3 into 2, 3 into 0. Then we get this matrix, final matrix. So this is the law of the matrix. If we are going to multiply any scalar to the matrix A, that is Ka, then the whole matrix is multiplied by with that element. This is called the scalar multiplication of the matrix. Now, properties of the scalar multiplication. So if we are going to multiply KHA, then we can write KH into A. K plus H is equal into A is equal to KA plus HA, or K into A plus B is equal to KA plus KB. These are the properties of the scalar multiplication. So next, the M cross N 0 matrix is denoted by 0. It is a curly 0. Is the M cross N matrix whose elements are all 0. That are in a class, in a face-to-face class, I also discussed there are so many types of 0 matrix, either 2 by 2 matrix 0 0 0, and 1 by 1 cross 3 matrix 0, and 1 cross 3 cross 1 matrix. There are so many types of 0 matrix, and it is called the 0 matrix. For example, this is a matrix 2 by 2 matrix 0 0 0 0, and it is a 2 by 2 0 matrix. And another example, it is a matrix 1 by 3 matrix. Remember it, whatever the first element we denote by the row, and the second element, it is a 1 cross 3 matrix. It means that it is a its rows is 1 and column is 3. Similarly, it is a 2 by 2 matrix. It means 2 rows and 2 columns. Now another example, this is the law. If we are going to add the 0 matrix to any matrix, then we get the same matrix. A plus 0 is equal to A. as this law is hold in normal algebra. If you have, then we see that a plus 0 is as, a plus minus a is equal to 0. Yes, it will, this law is also hold in normal algebra. So 0 into a is equal to 0. If we are going to multiply the 0 matrix with any matrix, then we get the 0 matrix. These are the laws of the 0 matrix. Now multiplication of matrices. So the multiplication of matrices is easier shown that put into words. You multiply the rows of the first matrix with the column of the second, adding the product. These are the laws that we follow with the multiplication of the matrix. So, for example, we have two matrices. One is A. In A matrix, we have two rows and three columns. And as we observe that in matrix B, we have three rows and two columns. If this law is happens, then only we can multiply these two matrices. And if A has 3 by 2 matrix and B has 2 by 3 matrix, 3 by 2 matrix, then only we can multiply. If this procedure is not complete, then we cannot multiply the matrix. So from this method we can multiply the matrix. So find AB. So first we multiply across the first row and down the first column, adding the products. We put the answer in the first row, first column of the answer. This is the procedure how that we can multiply the two matrices. Now I am going to show how we can multiply. So first I take first row and first column. This I will multiply first row with the first column. Then we get the first element. So first of all I multiply 3 with 2 and minus 2 minus 1, then adding 1 minus 3. With this we get the first element. So first of all I multiply 3 into 2, 3 to the 6. Then again on the next time I multiply minus 2 minus 1, 3 to the 6, and on the next time I multiply minus 2 into minus 1. So we get something minus 2 minus 1. On the third time I multiply 1 into minus 3, 1 into minus 3. So what we get? We get 5. So this is the first element of our new matrix. So this is the procedure we are going to multiply. This is the procedure we are going to multiply the two matrices. So I am repeating once again what we do. If we have a two matrix, then we take first row, first column, then we multiply first element, then we add second element, multiplied, then again we add, then we add third, we multiply third element, then again we add, then we get the 5. So 5 is the first element of the new matrix. So do you have any question of this? Okay. Yes, K is the scalar of the matrix. Yes, scaling 3 times. Okay. K is a scalar. Okay. Do we have to add? Yes. Now we move further. Okay. Now we move further. Okay. Yes. So we get this, find AB, and 1 multiplied by 3, and we get the 5. We get 5. 5 is the first element. So again, I will do, now we take the second row and second column. Now I'm going to multiply second row. So we multiply, no, but we take same. We want second element. So first we multiply first row and second column. So 3 multiplied by 4, and we multiply across the first row and down the first column. So we put the answer in the first row. Okay, in this way we can multiply. We get the 5, as in the previous slide I show you how we can get the 5. Now we multiply across the first row and down the second column, and we will put the answer in the first row and the second column. So again I multiply 3 multiplied by 4 and plus minus 2 multiplied by 3, 3 multiplied by 4, and plus minus 2 multiplied by 3, and I write it over here. And again what I have to multiply next? 1 multiplied by 1, 1 multiplied by 1. So this will, I get the 7. I get the 7. Now I write this 7 inside the matrix. This is our matrix. Now again, what we have to move? Now again I will take the second row and the first column. So I will move. Now we multiply across the second row and down the first column, and we will put the answer in the second row and first column. As the same procedure I am repeating once again for the second row. So I will multiply 0 multiplied by 2 and plus 4 multiplied by minus 1 and plus minus 1 multiplied by minus 3. So I first of all I multiply 0 multiplied by 2 and 4 multiplied by minus 1 and minus 1 multiplied by minus 3. So we get minus 1 in this. We get minus 1. So I put minus 1 over here. So again, the third, I want the second row and second column. So I will multiply the second row with the second column. So first of all I will multiply. Now we multiply across the second row and down the second column, and we will put the answer in the second row and second column. So I will show you how we multiply. Wait a minute. Can you see the blackboard clearly? Fahad, can you see the blackboard PowerPoint slides clearly? Yes, okay. Okay, no problem. Okay, it's clear. So now the yellow sign is not, we multiply. So this will complete, and so this will, the whole matrix is complete. Notice the size of A and B and the size of product AB. Now we multiply across the second row and down the second column, and we will put the answer in the second row and second column. To multiply matrices A and B, look at their dimensions. We have M cross N matrix and N cross P matrix. So must be the same. As I told you earlier that if we are going to multiply, then only I can multiply when we have M cross N and N cross P. If these two things are N and to N are not same, then we cannot multiply these two matrices. So size of the product M is, it does not matter if M or P are different, then it does not matter. It does not mean. If the number of the columns of A does not equal to the number of rows of B, then the product of AB is undefined, or we cannot define it. Now let's look at the product BA. If we are going to multiply B into A, then we have to choose first row and first column, and similarly first row, second column, then first row, third columns, and then again we choose second row, first column. On the same matter, we can proceed. We can go further and further. 3 by 2 can multiply by 2 by 3, and 3 and 3 size of answer. So this is the way of across the first row. As we go down first column, 2 into 3 plus 4 into 0, we get 6 first element. Now again, this is the procedure. Now again, I want to multiply across the first row. As we go down the second column, what we get? 2 into minus 2 and 4 into 4, we get 12. 12 I write over here. Then again across the first row, and we go down the third column, what we get? We get the minus 2. So in the same matter, similarly across the second row, and we go to the first column, we get minus 3. Then again I will go across the second row, and we go down the first column, we go 14. Similarly we can find. So on the same matter, you can find rest of the matrix. Okay, so Fahad, I will give you the mic. If you feel any problem, then whether the slides are not shown on the blackboard, then you will tell me, because of I am on the PowerPoint slides and I am unable to find whether you are seen or not. So I will give you the mic. If you have any problem, the PowerPoint slides are not shown you, then inform me. Okay. So we move further. So this is complete. And this is the product of the matrix, and how we can multiply. I show you from this way we can multiply uh, the whole matrix. So completely different than AB. What as I told you in the face-to-face class, the matrix AB does not is equal to BA. So don't confuse with this. A and B are totally different than B and A. So AB does not is equal to BA. In a class, I show you the example. I will give you the example of AB does not is equal to BA. So this is the proof. So now I'm going further. Properties of a matrix multiplication. These are some properties. If we have A into B, C is equal to AB into C. And second, if we have A into B plus C, and it is equal to AB plus AC. And if we have A plus B into A is equal into C is equal to AC into BC. These are the three properties that we use in matrix. But AB does not is equal to BA in matrix. Is it possible for AB is equal to BA in matrix? So we say that in certain case, in particular case, it may be possible, but in general it is not possible. Yes, it is possible only for certain case. Identity matrix. And N cross N matrix with 1 or on the main diagonal and 0 elsewhere. It is called the identity matrix, in which a main diagonal is 1 and rest of the diagonals are 0. It is called the identity matrix. So do you have any question from rest of the part? Okay. Okay. And you have clear till now, as I discussed, you have clear, I think. Okay. Now we proceed further. Identity matrix. So this is an identity matrix. So it is a 3 by 3 identity matrix in which we have 3 rows and 3 columns, and the main diagonal is 1. It is called the identity matrix. It is a 3 by 3 matrix. And this is a question that what is AI? If we have any matrix A, and we have an identity matrix, and if we are going to multiply A into an identity matrix, then what we get? So it is same as the normal algebra. So if what happens if we are going to multiply 3 into 1, we get the 3. If we multiply 4 into 1, we get 4. So in the same matter, in matrix, if I am going to multiply any matrix with an identity matrix, then we get the same matrix. So let us see. 2, if we have a matrix 2 minus 2, and this is a matrix, and what is IA? So IA is also, and IA is also same. This, whether I multiply over here or here, we get. So multiplying a matrix by the identity gives the matrix back again. We get the same result if we multiply the matrix with identity. So can we find the matrix to multiply the first matrix by to get the identity? So is there anyone to know what we get, what the thing that we get multiply it to get the identity matrix? Think about it. What we can multiply over this? I will give you 1 minute. Just think about it. Yes. So this is the answer. If we are going to multiply with this, and we get the identity matrix, or either we multiply from right hand side or we multiply from left hand side, we get the identity matrix. So let A and B, then n cross n matrix, if there exists a matrix B such that AB is equal to BA is equal to AI, then we call the matrix the inverse of A, and it is denoted by A inverse. So this is the solution. So no one give the answer of this. So on the class, I told you how we can find the inverse of the matrix. So this is called the inverse. -1 by 2, 2 and 3 by 2. This is called the inverse, and it is a procedure. To find the inverse, there is a procedure. So this would get the. So if A has an inverse we say that A is non-singular. If A inverse does not exist, we say A is singular. So there are two things, singular and non-singular. So in a class I earlier discussed what is singular and what is non-singular. So if we have a matrix A is equal to find the inverse of the matrix, we put the matrix a line, and then the identity matrix. We then perform a row operation on a matrix to turn it into the identity. We carry the row operations across, and the right hand side will turn into the inverse. So this is the procedure, in which procedure we can find the inverse of the matrix. So this is the procedure. First of all, we write the matrix, and on the right hand side I write the unit matrix on it. And then what I do, I apply the row operation on this matrix until we get the left hand side become the unit matrix, and whatever we get on the right hand side, that is the inverse of the matrix. This is the procedure that I showed you in my face-to-face class. So now again I am going to show you how we can find the inverse of the matrix. So there is a row operation. So or to find the inverse of the matrix, we put matrix a line, and then the identity matrix. We then perform a row operation on the matrix to turn it into the identity. We carry the row operations across and right hand side. So will turn into the inverse that I show you. This is an identity matrix, and we apply the row operation over it. So first of all, I want first operation I want, because of I want 0 in below the 1, so that's why I apply the row operation 2r1 plus r2. So with the help of this I get the 0 from row 1. Then again I apply the row operation, because of I want to remove minus sign from 1, so that's why I apply minus r2. Then on our next target, I want to remove 3. So in place of 3, I want 0. So what operation I want to apply over here? So the row operation I want to apply over here is R1 plus, but R1 minus 3 times R2. I think so. This operation I have to apply. R1 minus R2, no, it's R1 minus 3 times R2. It's the signature is wrong. It is wrong written. R1 minus 3 times R2. It is R1 minus 3 times R2. It's written wrong in the slide. So with the help of this, I get the identity matrix on left hand side, and I get whatever I get on the right hand side. This is the inverse of the matrix. So I get 7, 3, minus 2, minus 1 is the inverse of the matrix 1, 3, minus 2, minus 7. So this is the procedure. So we get 1 is on the left side, and 1 this matrix is on the right side. So this is A is equal to 1, 3, and A inverse is equal to 7, 3, minus 2, minus 1. Check this answer by multiplying. We should get the identity matrix if we have found the inverse. So hopefully you understand this procedure. Dear Abu Bakr, are you getting my points? How we can find the inverse of the matrix? Imam? Okay. Imam, now you can find the inverse of the matrix, dear Imam? Yes, okay. Now we move further. Okay, I hope everyone understands. Now I move further. This is the main thing that I want to, a main thing of our today's lecture. That's how we can find the inverse of the matrix. So if we are going to multiply A into A inverse, we get the identity matrix. So now we can use A inverse to solve the system of equations. So this is another method. If we have, it is the same method, but if we are giving a system of equations, then how we can find the A inverse, and how we can find the value of x. It is the same procedure as I discussed earlier, but here only just given the system of equations, and then the procedure is same as it is previous. So I'm going to show you. So to see how we can write the system of equation as matrices. So here we are given the system of equations ax is equal to b. This is the coefficient matrix. A is the coefficient matrix, and x is unknown and variable matrix, and b is the right hand side or the constant of the matrix. So coefficient matrix are given by 1, 3, 2, 5 as on the left side, and our variables are x and y, and our right hand side or b is 1 and 3. These are our right hand side. So now ax is equal to b. So left multiply both sides by the inverse of a. Then what we get if we are going to multiply both sides by a inverse? A inverse into a is equal to identity, and identity x is equal to a inverse b. We get a inverse a is equal to, this is just the identity. So we get identity of x is equal to a inverse b. So this formula we have to remember. Using this formula we solve that thing ix, yani x is equal to a inverse b. But the identity times of the matrix just give us back the matrix. So we have x is equal to a inverse b. So remember this point, x is equal to a inverse b. We use this result later, and this then gives us the formula for finding the variable of the matrix, multiplying by the constants. So it is x plus 3y is equal to 1, and another time 2x plus 5y is equal to 3, and we have a matrix A is equal to 2, 3, 1, 3, 2, 5, and find the inverse. So as the usual procedure on the last slides I show you. So first of all we write the matrix and draw the one straight line, and on the right side I draw the unit matrix. So what our aim is to write a unit matrix on the left hand side. So to mark a unit matrix I have to apply the row operation. To apply the row operation I want 0 in place of 2. So I have to apply this operation minus 2r1 plus r2. So with the help of this operation I get 0 over here. Again time, I want to remove minus sign from here. So I will multiply minus r2 from over here, then minus sign is removed. Then again I want to remove 3 from upper side. So I will multiply, in place of 3 I want 0. So I again apply r1 minus 3r2. So I get the identity matrix on the left hand side, and whatever I get on the right hand side, this is called the inverse. So the inverse of the matrix is minus 5, 3, 2, minus 1. This is the inverse of the matrix. This is the inverse. So now our next thing, we are going to multiply. We want the value of x and y. So our formula is x is equal to a inverse b. As in the previous slide, I show you this x is equal to a inverse b. So in this we want to find the value of x and y. So put this value in this. So x is equal to a inverse b. So we multiply, we write a inverse and the value of b. So first row, first column, we get 4. And similarly, second row, second column, we get another thing. So these are the values of x and y. So this is the procedure from it. So hopefully you understand. Yes, hopefully you understand the slide. So now there are extra some extra problems that I will discuss. The lecture is complete over here, but I will discuss some extra material. So and these are called the ith row vector, and this is called the jth column vector. A square matrix m is in a square matrix m is equal to n, and this is called the diagonal matrix. If we have a diagonal element, this is called the diagonal. Only rest of the part is 0. It is called the diagonal matrix. Trace of the matrix. If we are going to add the diagonal element, then we say that it is the trace of the matrix. Trace of the matrix is if we are going to add all the diagonal element, that is called the A. For example, if we have this matrix and there are R1, R2, these are some certain types of matrix, C1, C2, C3, these are some certain types, and two matrices are called equal matrix if A is equal to M cross N and B is equal to M cross N, then A is equal to B, if and only if Aij is equal to Bij. This is called the equal matrix. And equal matrix, for example, it shows that if we have one A matrix A and B matrix, and if A is equal to B, then A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. Then we say that the two matrices are equal. So again, I show you how in the previous slide I show you with the example, but here it is general matter. From the general way, it shows that how we can add the two matrices. So if we have two matrices, then we can add these two and we get the same. We get the result -1 plus 1 is equal to 0, and similarly 2 plus 3 is equal to 5. So these are the just matrix subtraction. If we are going to subtract the two matrices, then this is the procedure. If we have two matrices and we are going to subtract them, and if we are going to multiply 3 with this matrix, then what we get, we have to multiply each and every element with the 3 to the matrix. We get the result. This is the procedure to multiply each and every element. So if I am going to multiply a matrix by minus sign, then what we do, then it means we have to multiply minus inside the whole of all the elements. So we have to multiply the minus sign in all the elements. So -2, -0, 0, and -1. Rest of the elements become 0. So if we have a matrix, if we are going to multiply 3a minus b, so it is easy to subtract. First of all, I write 3a, then minus b, then 3a minus b. We get the result 1, 6 minus 12. This is the procedure to find find. Now next question is example for find AB. How we can multiply these two matrices if we have given two matrices. So again, I'm telling you, first of all, we multiply first row and first column, and again first row and second column, then again on the same procedure. This is the procedure as I told you in the previous slide. From with the help of this procedure, I can multiply these two matrices, and we get this answer. So matrix form of the system of linear equations. This is the matrix form. In this form, we can also find if we have m system of linear equations and m unknowns, then we can find the solution of the system of linear equation. So partition of matrices, submatrices it is called. These are some definitions. Properties of matrix operation. So three basic matrix operation: matrix addition, scalar multiplication, and matrix multiplication. With the help of zero matrix is denoted by 0 and m cross n, whatever. Identity matrix of order n is denoted by I. And properties of matrix addition and scalar multiplication. As I told you, the matrix addition is commutative. That is, A plus B is equal to B plus A plus B plus C is equal to A plus B plus C, and this is called the this is called the these are the rows. If we multiply any matrix with the identity matrix, we get the same matrix. And the properties of the zero matrix, if we are going to add the matrix with the zero, then we get the same matrix. And if we are going to add the matrix with the same matrix, then we get the zero. And similarly, if we multiply C with any matrix and it will become 0, it will happens only and only either C is equal to 0 or A is equal to 0. It means any one thing is, if in a normal algebra, if we are going to multiply the k into 3, k is anything, and it will become 0, then it means either k is equal to 0 or 3 is equal to 0. So this is the procedure. These are the rules of the matrix. 0 into m cross n is additive identity for the set of m cross n matrix minus A, the additive inverse of A. So transpose of the matrix, if we have this matrix and we are going to find the transpose of this matrix, then it is just inverse. Row become column and column become row. It is called the transpose of the matrix. So if this is first row and this is first column, yani it will remove from first row become first column, and second row become second column, and third row become third column, and nth row become mth column. So this is the procedure to draw the transpose of the matrix. So over here there is a question: find the transpose of the following matrix. So we have given a matrix with one column and two rows. So what is the transpose of this? So we are given A is equal to 2 8. So the transpose of A is 2 and 8. Any 2 become vertical. Similarly, we can find the transpose of B and C and D. So this is the procedure from which we can understand. Okay. So now I can find the transpose of second matrix. If we have this matrix 1 2 3 and 4 5 6 7 8 9, and I want to find the transpose of this matrix, then I will convert a row into the column. So first row become first column, so it will the transpose of this matrix 1 2 3 4 5 6 7 8 9. This is the transpose of the matrix. So again, if we are going to multiply C, if this is a matrix 0, 1, 0, 1, 2, 4, and what is the transpose of this matrix? So row become column. So this is the transpose of the matrix. So this is the procedure to find the transpose. Now the properties of the transpose is a transport of the a transpose of the matrix. The transpose of a transpose is equal to A. A plus B transpose is equal to A transpose plus B transpose. C A transpose is equal to C into A transpose. A B into transpose is equal to B transpose and A transpose. So similarly, there are various type of matrices. Symmetric matrix, A square matrix, A is symmetric if A is equal to A transpose, and skew symmetric, A square matrix, A is skew symmetric if A transpose is equal to minus A. For example, if a matrix is given is symmetric, find ABC. So if first of all we find the transpose of it, and if A is equal to A transpose, then A is equal to 2, B is equal to 3, and C is equal to C. Similarly, if A is equal to this is a skew symmetric matrix, find ABC. So first of all we find the transpose of this, and because of A is equal to minus A transpose, so if the value of A is equal to minus 1, B is equal to 2, C is equal to 3. So A transpose is symmetric. So there are some various examples so that AB and BA are not equal for the matrices. So in a class, in a face-to-face class, I give you this example. If we have AB is equal to this, if we are going to multiply these two matrices, we get this matrix. And after, if I going to multiply BA, we get the different matrix. So with the help of this, we conclude that AB does not is equal to BA. AB does not is equal to BA. So an example which cancellate is not valid. AC is equal to BC. AC is equal to this element, this matrix, and BC is equal to this element, this matrix. So AC is equal to BC, but A does not is equal to B. So these are some various examples. So this is the end of your lecture. So do you have any question about this lecture? Okay. Okay, welcome. So I hope you are clear, and this lecture is very clear, because of in a face-to-face class, most of the people are not understand well. So in a PowerPoint slide, it's very clear. Okay, thank you. Okay, welcome. Okay, good night. Take care.